Solve logarithmic and exponential equations. An exponential equation is an equation containing one or more expressions that have a variable exponent. We already know this. That's what we've been studying this whole unit. Now, there are two different ways that we can actually solve exponential equations, and we're going to talk about that a little bit in this video. The first way to solve an exponential equation is to write with common base and then set the exponents equal to each other. The second way that we can solve exponential equations, and this way always works. Sometimes it's tough to set it with a common base, but the next way is to take a logarithm of both sides and then use your logarithmic properties to simplify your equation. Those are your two ways, and we're going to go over a few examples next. In this first example, we just want to solve the exponential equation. We have 9 to the power of 8 minus x equals 27 to the power of x minus 3. So in this one, let's try to change it to a common base. If I change this 9 to a 3, well, because I can change it to a 3 because I know 3 squared is 9. So that would be 3 squared. But we also have that 8 minus x. So that's still in the exponent. So 8 minus x. And that is equal to, well, can we have a base of 3? 3 to what power gives me 27? 3 times 3 is 9, times 3 is 27, so that would be the third power. 3 to the third power is 27. Okay, and then again, that x minus 3 is still in the exponent. All right, well now I have a base of 3 and a base of 3. Well, that just tells me that if we have a common base, then that must mean that our exponents have to be equal to each other. So we can set those equal to each other. 8 minus x equals 3 times x minus 3. All right, at this point we simplify, so we can distribute, and that would be 2 times 8, which is 16, minus 2x equals 3x minus 9. And then if I continue simplifying, add the 2x. Then I get 16 equals 5x minus 9. Add the 9. 25 equals 5x. So that means that x equals 5. And that is your final answer. And then if you plug it in to check your work, you should get x equals 5. In this next example, we want to solve the exponential equation, and we have 4 to the power of x minus 1 equals 5. This time, we cannot just make a common base because there's no way we can make 4 and 5 a common base. So in this time, we are going to take the logarithm of both sides and use our properties. So that would be log of 4 to the power of x minus 1 equals log of 5. We just have to do it to both sides. Now, our properties tell us that we can take the exponent and bring it up front to the front of the logarithm, giving me x minus 1 times the log of 4 equals the log of 5. Now, at this point, we just solve for x. What we have now is actually a number times x minus 1 equals another number. So what I'm going to do is I'm going to divide by the number log of 4. And then I can cancel it out like I always do. But if I do it to one side, got to do it to the other side. So what I have is x minus 1 equals the log of 5 divided by the log of 4. At this point, if you want to, you could type that into your calculator and get a decimal answer. But we do have one more step. We got to get the x by itself. So you add the 1, and your final answer is x equals the log of 5 divided by the log of 4 plus 1. Okay, so that is your exact answer. Your estimated answer, if you typed it into the calculator, hitting the log button 5 divided by the log button 4, and then plus 1 at the end, then you should get about 2.161. So that would be your estimated answer. A logarithmic equation is an equation with a logarithmic expression that contains a variable. So very similar to the exponential, except it has a log instead of things in the exponent. You can solve logarithmic equations in a couple of different ways. When you have a common base on both sides and only one logarithm on each side, then you can set the inside of the logarithms equal to each other, very similar to the way we did with exponents. The second way, and the more common way, is to what we call exponentiate, using the base of the logarithm to eliminate the logarithm. So we want to make it an exponent so that we can cancel it out using our logarithm properties. In both these cases, we will have to use those properties in order to solve the logarithm. So we'll do some examples of that now. So in this first example, we have log base 6 of 2x minus 1 equals negative 1. Since I only have one logarithm, I'm going to do option 2, where I exponentiate. So that means I'm going to make that log base 6 of 2x minus 1 an exponent. And since my base is 6, it's going to be 6 to the power of log base 6 of 2x minus 1. Now, if I do it to one side of the equation, I must do it to the other side of the equation. So I have 6 to the power of negative 1. So what that is actually going to give me is, canceling those out right there because they have a common base, that's my logarithmic properties, I have 2x minus 1 equals 6 to the negative 1 power. Well, you should recognize that 6 to the negative 1 power is actually just 1/6. Okay, and that's what we know from before. So I have 2x minus 1 equals 1/6. And then I add the 1. So I have 2x equals 7 over 6. Divide by 2. So that's going to give me x equals 7 over 12. And that is your final answer. It should be written as a fraction in this case because we should not need decimals for a fraction like 7 over 12. This next one, to solve this logarithmic equation of log base 4 of 100 minus log base 4 of x plus 1 equals 1, I want to start by combining it into one logarithm because it's easier to deal with one logarithm instead of two. So using the minus there, I'm going to put them together into 1 log base 4 of 100 divided by x plus 1. That's my quotient property. It says I can put them together like that. Equals 1. And now I'm at basically the stage I was at the last example. I want to exponentiate. So base 4, so I'm going to take 4 to the power of log base 4 of 100 over x plus 1. And then it's 4 to the first power. So nothing has changed. So now what I have is, those cancel out, giving me just 100 over x plus 1 equals 4 to the first power is just 4. Now I need to solve a rational equation. Again, something we've already done. So I'm going to multiply by my denominators, multiply by x plus 1, and I have 100 equals 4x plus 4. And now I solve. So I'm going to subtract the 4 minus 4. And I have 100 minus 4, which is 96, equals 4x. Then I want to divide by the 4 so I can solve for the x. And x equals 24. And that is your final answer. And then you can plug it back in, make sure it works, and it does work. That's it for your notes over solving exponential and logarithmic equations. You definitely need to work on some practice problems of these types of problems because it is tough when you're first starting to understand how to solve these two different types of problems. So go through the practice problems and then you can prepare for your quiz over this material.